and he left for UCL to complete his PhD in ML. During his period as a PhD student, he co-founded UserContext.ai along with his supervisor. After completing his PhD in 2017, he joined as a research scientist in Spotify, specializing in machine learning for marketplace and rankings. He is also a fascinating individual, and we're grateful for his presence among us today. Without further ado, please join me in welcoming Dr. Rishabh Mehrotra.
Hi, everyone. Thanks, Varun, for the introduction. And thank you, BITS CSA, for organizing this Alumni Research Talks. So I've had a great history with CSA and Alumni Research Talks as well. So I'm going to talk about some of that as well later on. And thanks for the organizers for putting the hard work and setting this up for you guys, especially in this COVID times when everybody's remote and things are a little harder than usual. So great. So today we have about an hour, and in this hour, I'm gonna discuss some of the research work, some of the background I have from BITS, and also share some tips or some comments from my side on how we can get started with doing research while you're at BITS. So in terms of the main topic, in as per research, I'm gonna focus on optimizing for multiple objectives for recommendations in marketplaces, and then we'll see kind of how we can kind of think about some related research problems. Cool. So as I said, I'm going to start just briefly talking about myself and my BITS journey. I'm going to give you a slight introduction to the problems we might face at Spotify. Spend about half an hour talking about multi-stakeholder recommendations, multi-objective machine learning. And then I'm going to allude to something more generic, which is some kind of public data sets which we have available, and some comments on getting started with research. So again, it might be a little rushed, but I'm going to skip through some of the slides in between. Perhaps I really want to get to the last two parts, at least with 20 minutes remaining. So we'll see how this goes. Great. So yeah, I did my PhD from UCL in London. I was supported by a Google Research grant. Again, at BITS, I was at BITS from 2008 to 2013. Did my degrees in computer science and mathematics. And in general, I've kind of during my PhD intern a bit at Microsoft Research and worked at Goldman for a brief while. So in general, as I said, I started at BITS in 2008, and so I gave I dropped a year after my class 12. I got the same BITSAT score. I started in 2007 with 302, ended in 2008 as well with 302, which is fun. Again, in terms of GPA, it's not that great, 7.83. But if you look at the bifurcation, so I'm B4A7, right? So B4 is mathematics, A7 is computer science. So yeah, so my maths degree courses were really screwed up. So I kind of average a 5 there, and in the A7 it's 9.1 because back then I didn't know what kind of value these math courses could have had. I'm going to come back to some of these why we should pay more importance to some of the other courses and not just the computer science courses. And I have a slide later on towards that end, and I've learned quite a few things from there. Again, my association with the computer sciences talk, CSA, has been huge. I started in the first year as a volunteer and a SOC member, and then I went on to become the Apogee coordinator and then the president in 2011 and 12. So this is close to 10 years ago, and in others as well. So I'm from Lucknow. So I was part of the Sangam association. I was a president for there. I was part of the Astro Club, Astronomy Club, which is a great club which we still have, hopefully, in the campus right now. So during my time at BITS, I kind of struggled hard to kind of get internships, because if your GPA is not that great, then it might come in a bit more harder for you. So again, I did get a chance to kind of intern at the NICTA lab and University of Houston, wherein I did my thesis. I did my PS2 in my 5.2 at Nolscape in Bangalore, which was a startup, which is still a good company around in Bangalore right now. Yeah, so again, just a brief pictographic view of the journey there, right? It started in 2008 with the Ramba one. Some of my batchmates who are at many different places right now. This is one of these in the FD2. We have this room 2201, I think. So that's the Apogee meeting. Apogee, I guess the first years would know by now, is the Tech Fest which we have at BITS. Again, at Apogee 12, this is a bunch of 4 of us trying to kind of complete these midnight projects, and we kind of won a few things. So in general, so this is some of these pictures from the Astro Club. We have this huge dome at the terrace, celebrating some of my Wingy's birthday with fire, and Sangam as well. Yeah, and like this is the picture from my farewell at SAC. And I mean, there's no farewell at BITS without you getting bumps, even though you were the president or the coordinator. So that happened. But in general, like one of the interesting things to point out is that so we were the first teams behind setting up this alumni research talks. So along with a few seniors like Vineet Pandey, Swapnil Hike, they are at like many different, like Vineet is at Harvard right now, Swapnil is at LinkedIn, and Rishabh is at Google. So again, like we were the initial team launching alumni research talks. So it's a great honor and privilege to come back as a speaker now after like 9 years of this. So again, like we had it in person. So this is Swapnil. He's now a principal staff engineer at LinkedIn, and we kind of spend a lot of money in like getting these like tablecloth printed out and stuff. And it was a lot of it got a lot of interest from the audience as well. And I mean, on the front row, you could see like me seated there. So in general, this is a team with these speakers. So again, like I really believe in the value which alumni who have had research experiences could bring in, because there's a lot of things which I wanted to do 10 years ago when I joined BITS and I didn't. So I mean, I really appreciate the people in CSA kind of going ahead and like continuing organization of this alumni research talks. And I hope the next week for you guys could be like really useful. You could build connections with the alumni. I hope you can kind of take away a few messages on what might work, what might not work, and so on. Yeah, and more importantly than that, like have fun in the this week with all these talks. Right. So this is a quick 5-minute introduction. I'm gonna spend another half an hour talking about just Spotify and some of the machine learning problems there. And these are like some specific examples of what kind of machine learning problems we are solving at scale. And then I'm gonna abstract away and like talk in general more as a Bitsian, right? That how can we kind of get started with doing research? And this is not at Spotify. This should be research at BITS. Sorry. Right. So if you look at Spotify, right? So Spotify is a platform which connects listeners and creators. So our team's mission is to connect listeners and creators in a unique and enriching way. So what we are talking about, this might be a bit more outdated numbers, but I mean it's a large scale problem, right? That you have like 144 million subscribers, your number of tracks are like 60 million plus across 92 markets, and like you're looking at a total of 300 million plus users using the platform. So again, any tool and technique you develop has to scale well. And if you're talking about 60 million tracks, then recommendation is a very important problem, right? Because of these 60 millions, I might just be familiar with like 6,000 tracks at max in my 30 years of my life on Earth, right? So how do we recommend content from this like huge pool of information is very challenging. So this is like some of the problems we kind of tackle. So again, like just to give you a flavor, that when you start looking at an app, then one thing which would be nice is like if you start looking at what kind of machine learning problems could be behind some of those features, right? So if you look at these playlists, so we have these playlists and each playlist would have a ranking. So what kind of playlist can we have on the platform, right? So I mean, should we create a new playlist for dance music, for bhangra music, for any other aspect which might come in? We don't know. So again, like understanding user behavior, looking at what users want, and then creating these playlists is a bunch of machine learning problems right there. If you look at radio sessions, so if you start a radio session from a track, then you're looking at a sequential recommendation problem. So you have a track and the user might like it, the user might not like it, and then in general, based on that, you want to be very adaptive, and like you want to change your recommendations based on the user feedback. So again, a very interesting sequential machine learning problem. If you look at search, right? So search is typical, like Google, Bing, and all these search engines have this problem that the user types in a query, and you have a query, and then you have to retrieve relevant results. So it's a learning problem. It's a learning to rank problem as well. So again, like we talk about home. So homepage is the default page. So if you go to Netflix, if you go to LinkedIn or even Facebook, you have this problem of creating a diversified home, which gives a holistic experience to users. So again, a bunch of different machine learning models go over there. And finally, like you have these different genres and move hubs, right? So in general, if you look at these, right, then each of these has a different set of machine learning problems, which we as researchers or ML engineers will have to think about and understand. And then like each of these are powered by different types of machine learning problems. So like search is a learning to rank model. You have a query and then you have a bunch of documents. So if you go to Google, type in a query, we have to retrieve documents, and that's information retrieval. So that's a slightly different area of machine learning than, let's say, radio. So radio is sequential in nature. So I have a sequence of user interactions and I want to optimize for user satisfaction. So again, the bunch of different machine learning problems all scattered around across different touch points which users have with the app. And this is not just for Spotify, right? I mean, if I go to LinkedIn, if I go to Netflix, if I go to Facebook, each time I get recommended some content, there's a huge amount of machine learning going behind the scenes. So again, like one of the takeaways you might have here is that when you start interacting with like things on your phone, you might want to think about what kind of machine learning problems are there behind this particular app or behind this specific feature in this app which I'm using. So again, like let me talk about recommendations for a bit. So Spotify, a large part of machine learning we do is around recommendations, right? So in general, I'm going to spend 5 minutes talking about like the last 20 years of recommendations and where the world is right now and what's coming next. So this is a quick, very, very quick introduction of literally like compressing 10 years of research in like 15 slides on what has been going on in recommender systems. So again, recommendations is a problem wherein you have a users, you have huge number of items. Items could be for Spotify, it's music or playlist or podcast. For Netflix, is movies or shows, and so on, right? So basically, the challenge is that we have huge amount of content in terms of items, and the user's attention is limited. So what kind of content should I recommend to the user? So that's the key problem which recommendation system solves. I'm pretty sure like 90% of you already know this, but just in case, we have few people who want to understand what recommendations actually means. So Rex is just recommendation systems. Cool. So we started like 15 years ago, one of the best performing models was matrix factorization. So basically you have users and you have items. So items could be like songs or movies. So for each user, you can create you can create this huge matrix, and you have for each user what all items have they liked or what all items have they consumed. So you have this like sparse matrix. Matrix is sparse if it's not very full, right? So as a user, I never interact with 60,000 movies. I only interact with like 500 movies. So if you look at my row, then this is a very sparse row because almost 90% of the entries in this matrix are zero, because the user doesn't always interact with all the movies and all contents, right? So that's why we observe this like sparse matrix. And the goal is, can we do a matrix decomposition here? So matrix decomposition gives you two types of matrices. So one, you get a user representation, and the other, you get the item representation. So based on these two decompositions, you can pick one row for each user, and that's the vector which you use to represent your user. You can do the same for the item. And then you have these two vectors, right? And based on, you can do a cosine, dot product, cosine similarity, whatever, and then come up with a similarity for this user and this item. So again, like if I have 60,000 tracks, I'm going to do this cosine similarity with each of these 60,000 tracks and then pick up the top 5 to recommend to you. So again, this is what matrix factorization might look like. Again, when people realize that these matrices are very powerful, then they said, maybe I can extend it. So instead of just looking at a matrix, I can do a tensor. So tensor is just an extended form of matrix, right? So matrix is 2D, tensor could be 3D, 4D, and dimensional. So again, with tensors, you can incorporate a lot more information. So people did that. So they incorporated locations, they incorporated features and activities, and then they created these huge tensors. We did some work in like 2014, wherein we said that I'm going to create a matrix and share it with the tensor. So the matrix and tensor share the user representation, user side. So then we can do some joint decompositions on these and then kind of go on and use these representations to do recommendations. So again, we started with matrix, we can extend them to tensor. A lot of work also has gone into latent variable models. So again, if you look at the machine learning in the last 15 years, a lot of these projects were on latent variables. So latent variable is a hidden variable. So I do not know what the value is, but then I'm going to infer it. So again, like there's a lot of work around in the community which says that I'm going to create a new latent variable, do some GIP sampling or MCMC style sampling and infer my variables. So again, this is a very probabilistic approach to machine learning and like recommendations, which was around for like 10 years up until 2013, 2014. And then came in the neural embeddings, right? So I mean, Word2Vec and these deep learning embeddings, I'm guessing you might have heard, at least in the news, if not, have a technical exposition to it. But the idea over here is that I can learn an embedding. Embedding is just a representation, and representation is just a vector. So I can learn a vector for anything. It could be a user, it could be an item or anything, and then work with these embeddings, right? So if you remember, in the matrix factorization, we were also just learning embeddings, right? We were not doing anything much. We were doing a decomposition and then getting this embedding, which was a representation. And now we can do that with neural networks. So people started like using these embeddings for recommendations. So there's a Rexis paper which says that I have user, I have item, but I also have some side information. So if I can add that side information to my network, I can learn better representations perhaps. Or you can do like joint user item embeddings as well. And then like if you look at what happened, like matrix factorization was looking at all users together. And these embeddings are looking at user and item together. So then they came up with ways of combining both. So I can have the users and the items together while I retain the collaborative aspect. So collaborative was collaborative filtering across users. So again, like some joint neural collaborative ranking came into the community, and then these were performing very well 3 years ago. Now, these are some models, right? So some of these problems could also be short-term, long-term. So should I look at a user's profile only in the last week, in the last month, or should I create a long-term user vector? Cold start recommendations. So oftentimes what happens is that a new user comes in and I don't know anything about that user. So maybe how do I do recommendations for them? So again, maybe you kind of look at, does this user belong to some pre-existing groups? And I might know information about that group. So maybe I can do some group level inference and then do recommendations for those users. Again, if you look at a computer at your home, then probably a lot of people are using that computer, right? So if you have a Google Home at home or Alexa, then like 4 or 5 people use that Alexa. So there, the problem is like you have to create multi-interest model. That if I look at one day's data, then I should be able to disentangle that this session was perhaps caused by family member 1, this session was because of family member 2, and so on. So that you can do this assignment that which user is, to Google Home, you never tell that, hey, I'm this, and show me content or recommend me based on that. No. We expect them to know our preferences, and for that, they will have to do this like multi-interest modeling. And there's also a lot of work on multitask recommendations. So basically, multitask means that I want to optimize my ML model for multiple tasks. So I don't just care about one task, I care about 3, 4 tasks at the same time. And instead of creating 5 different models, I'm going to just create one model. So again, if you look at this, right, this is what has been going on in the community for like 10 to 15 years, right? So they have something in common. And the thing they have in common is the user-centric nature. And this is the main point which I want to convey, that in the last 10, 15 years, a lot of research in applied machine learning and recommendations across many, many companies, right? Quora, Amazon, Netflix, Spotify, like Swiggy, Zomato, all of these companies have mostly been thinking about user satisfaction. So they care about user interaction, they care about user satisfaction, they care about user returning to the platform. Everything is user-centric. And this is what I want to convey, that maybe caring about the user is not enough. So you have to care about the user. But then if you look at some of these platforms like Uber, so in Uber, you have to care about the driver as well. In Zomato, you have to care about the restaurants and the delivery partner. If you look at Netflix or Airbnb, so on Airbnb, you have to care about the host and not just the guest. So again, a lot of these problems are multi-stakeholder problems. And that's the paradigm shift which we are seeing now in the community and in the industry as well. That we should care about not only the users, but also the other parts. Like on Spotify, we should care about the artist. On Uber, you should care about the drivers. An example is that a driver doesn't want to wait for like 6 hours to get a ride, right? So you want to give equal opportunity to your suppliers as well. On Amazon or Flipkart, right? So if you go on Flipkart, if you want to sell something, you don't want no customers to get your product, right? Flipkart search controls a lot on what kind of products gets consumed. So again, like if you as a retailer are not getting shown to the user, then that's a bad thing. So often these platforms have to care about the supplier side of things as well. So suppliers could be the artists, it could be the Uber drivers, it could be the Amazon host, it could be the Amazon or Flipkart retailers, it could be the Airbnb host. And also you care about platform as well. So at the end of the day, the platform has to exist for a long time. So you do care about a lot of these platform objectives. So this is what I'm going to do. I'm going to quickly, in the next 20 minutes, I won't go very deep, but I'm just going to give you some touch points and some ideas around what kind of machine learnings do we tackle. So I'm going to start by talking about a user-centric model. So this was the model which was in production at Spotify like since 2018 or something like that. And this was like rolled out to all 200 million users. And this is a user-centric Bandit model. And then I'm going to talk about some recent work which we have done on multi-objective models. Cool. So again, like, yeah, this work is a joint work with a lot of my colleagues at Spotify, and we have a paper at Rex's in 2018, which has all the details if you're gonna go and have a look at like what we are talking about here. So if you look at the homepage of Spotify, then this is what it looks like. So we have these, we call these horizontal rows at shelf, and each shelf has a title, you heavy rotation or recently played, and each of these shelf has multiple cards. So a card is a playlist. So again, our goal is to create this homepage for you. So let's see how we can do that. So if you look at the homepage, then it should look like to you a stack of horizontal rows, right? Horizontal shelves. So each shelf is an explanation. It's kind of related to the shelf name. And inside each shelf, I can have multiple cards, and then I can stack multiple shelves one after the other and create the homepage. So the way we do that at Spotify is via balancing explore exploit. So explore exploit is a topic which is worth like 2-3 hours of discussion. But in summary, exploration means that I want to explore more. So maybe okay. So if I look at a user, then I might know something about the user, that the user really likes hip hop music, but I do not know whether the user likes pop music or not. So now if I want to exploit, so I exploit my knowledge that we know that the users like hip hop music. So I'm going to exploit that and show them hip hop music. On the other hand, I do not know whether the user likes Bhangra or not. Now that's the problem. Like, then I'll have to explore that among all the things which we do not know about the user, can I explore and show something to the user and then learn about the user? So again, maybe you've never interacted with like Bhangra music on Spotify, and it's just that we don't know whether you like it or not. So certain times we're going to show you Bhangra music and then observe whether you stream it or not. So that's the explore exploit. So oftentimes you want to exploit that I know my knowledge about user and I'm going to exploit that knowledge. But sometimes you want to explore and kind of widen your horizon of knowledge you have about the user. So that's the English philosophy of what explore exploit means. In general, what it boils down to is this bandit problem. So bandits are these, if you go to a casino, if you look at any casino online, then you're going to see these slot machines. So casinos have these slot machines wherein like if you pull an arm in that slot machine, you get a reward. So reward could be like $1, $2 or whatever. So exactly the same applies in recommendations, that a slot machine might mean a playlist for us. So basically the goal is that I do not know what the reward I will get if I pull this arm in the slot machine. So basically what it means is that if I have a bunch of 10,000 playlists, then for these 5 playlists, I know the user likes them to 0.7, 0.8, 0.6, but for the others, I do not know. So I want to trade off these decisions there. And here is where we kind of do this. So basically we create this action distribution. So an action is us recommending a playlist. So basically if I have 10,000 playlists, then I have 10,000 actions. And now I need to kind of infer the probability of this action distribution, that with what probability will I be picking up a track from this particular playlist or the other playlist. So again, like that's what the core playlist recommendation model is on the homepage. So you want to learn these action distributions. So basically what it means that you have an action set, which is M playlist. You have a reward function. Reward function says that, okay, you took an action. You decided to show this playlist. How much reward should I give you? Maybe the user loved the songs and they hearted the song. They streamed for like 1 hour. That's great. I'm going to give you a +1. Or maybe the user skipped a lot of these tracks and didn't like it. So I'm going to give you a -1. So the reward function decides how good your action decision was. And if you're getting high rewards, then that means you're taking right actions. And there's a policy, the exploration policy. So how often do you want to explore? Like how often do you want to try random things and show and learn about the user? So again, this is what it means in general. So now let's see, there's this explanation bit as well, that if you look at each shelf has a title, and that's the explanation. So the explanation is because it's Friday, or like shows you might like, or like getting cozy for autumn and so on. So now if you look at this problem, then naively combining. So basically what do we have? We have these horizontal shelves, and each shelf has a title, which is the explanation. And then we have cards inside these shelves. So naively trying all possible combinations is a combinatorially hard problem. And that will not converge, right? I mean, if I have to train a model with all explanations, with all playlists, with all shelf organizations, then it's like a very intractable problem. So the way we do that is by proposing this model, which is BART. So BART is a Simpsons character. The homepage team at Spotify loves Simpsons. So we kind of name the model as BART itself. So BART stands for Bandits, for recommendations as treatments. It has three parts. One is a user preference model. So user preference model says that if I get a user, if I get an item, then give me a probability how much of this item will the user like. So maybe that value is 1. I am very sure that the user will love this. Or the value is 0.1, that the user may not like it much. And this could be anything, right? This could be a factorization machine. It could be your favorite neural network model, deep learning model, or even a logistic regression model. So you have a user, some features from the user, some features for the item, and then you want to predict on a score from 0 to 1, what's the probability of the user liking this content. So again, like this depends on context, right? So context could be all the features we know about the user. It could be the time of day. It could be where you are, the region, like are you in India, are you abroad, your age group, listening patterns, and so on. We trained this model using counterfactual likelihood. This might take a while, so I'm going to skip that. And there's a ranking procedure. So the ranking procedure is what we're going to talk about next. Again, we make certain assumptions. So remember, like, exploring this combinatorial space is hard, so we have to make certain assumptions on horizontal and vertical scrolling. So what we do is like we start to create this shelves one at a time. So for a shelf, what I can do is I have a bunch of these playlists, and I have my action distribution, right, which I showed before, the pi of the pi function, which was the action distribution function. So what I can do is I can say that, okay, I have this distribution and I want to sample a card. So this says like select an action. So on the bottom, once this bar disappears, yeah, so if you say there's an action like select a playlist from that probability distribution and then show that to the user, and then repeat the same as you go horizontally on the right. So you pick up another card, you sample it from the same probability distribution, and then you show that, and you keep on doing that. So that will give you one shelf at a time. Now you have these shelves created. So now I can apply the same bandit model not on cards, but I can apply it on shelves. So now I have these horizontal shelves. Which shelf should I rank at the top? So I'm going to pick up one shelf. I'm going to apply another bandit, which is a second round of bandits. Again, sample from the probability distribution across these shelves and then show that. And then continue, but this time vertically. So this would give me this entire homepage. Now, importantly, how do I know whether I'm doing good or bad? Like, is this a good thing or a bad thing? That's a reward function, right? So reward tells us like how well we are doing. So a very simple version of reward could be that if the user streams less than, let's say, a few minutes, that's bad. I mean, our recommendation wasn't good. Or if the user streams more than, let's say, a couple of minutes, then this is great. I mean, I love it. And I'm going to give you a +1 reward. Now, these are very naive, right? I mean, this is the simplest thing you could do. But in general, the problem here is that you're applying the same function across all users, across all content. And this is like kind of stupid. So this is where, if you look at playlists, right? So there is variation across playlists. So if you look at this function, what should T be? So T is the minimum time you have to spend to get a +1 reward. Now, if you look at sleep music, then sleep music, people should stream for like hours and hours. Whereas if you look at some other music, then like people might not stream that for hours. So again, there is variation in the consumption time across different playlists and also across different users, that like jazz listeners consume music more than the average listener. So again, here we try to say that, okay, up until now, you have the same function. Regardless of the user, regardless of the content, I'm going to do the same thing, which is not good. So then we start looking at like distribution-based reward functions. So this is a paper which we had an intern, Paolo from University of Trento. He has finished his PhD now. So again, like we looked at how do we come up with like better reward functions. So what we did was we looked at these users and playlist, and then we did a co-clustering. So co-clustering is you cluster the users groups and the playlist groups together. And effectively what you get is this. So for each type of users and each type of playlist, I get a sort of distribution. And then based on that consumption distribution, I can decide what my reward function is. So up until now, there was fixed, like you were doing this fixed reward, like less than T is 0, greater than T is +1, but now you are distribution aware. And this gives you nice generalization that sleep music playlist will have a very different distribution, so your threshold will be very different for those type of content and playlist. So again, we tried this and it gave some pretty good results. And in general, the Bandit model we kind of productionized at scale. So I mean, since 2008, 2017, 18, if you've been using Spotify, then at least in 2018, the model which was serving you this was this contextual Bandit model. So again, there's a lot of machine learning behind this, which we did at scale. We productionized it across 100 million users, and this was one of the great success stories in like a couple of years ago. So again, just to take home message is that naive combinations makes the problem intractable. So now we have to break up the problem into horizontal and vertical shells. And bandits are a type of machine learning models which allow us to do this explore exploit over explainable content. Cool. I'm running a bit short on time, so I wanted to spend more time on the multi-stakeholder, but I'm just going to give you some nudges to it, and then you can look at a couple of videos which we have online as well on this work. So in general, as I mentioned, that up until now, this model only cares about the user, that we want to optimize for user satisfaction. So how can I create my bandit models for that? Now what we want to do is like, I want to go back and say that, okay, remember, we have multiple stakeholders. So I don't just want to care about the user. I want to care about other stakeholders as well. So how do I do that? So if you look at what we were doing up until now, right, we were saying that my recommendation policy should be, I'm going to maximize or minimize one function, and this function is user-centric. But now I want to do a multi-objective function. So instead of a user-centric function, I want to look at user objectives, I want to look at supplier objectives, and the platform economics itself. So how do I do that? So this means like I should balance multiple goals, multiple objectives. Now, what could these multiple objectives be? Just a quick example. So on user satisfaction, I want to look at stream time, that I want users to stream a lot of music for longer. I want to look at clicks, like are users clicking what I recommend to them? I want to look at items consumed, like what kind of playlists are you kind of consuming more songs, more podcasts on the homepage or not? On the artist side, I want to look at diversity of artists. So is it that all the like only Sonu Nigams or Ed Sheerans of the world are getting music, or are we surfacing enough of all these niche artists as well? So maybe there's a great band at the Pilani campus at BITS, and we want to give enough exposure to those artists as well, right? So again, that's the artist metric. Or we might want to we find out there's a certain segment of artists who are really not performing good, so we want to promote them a bit. So these are different objectives. And if you look at on the right, we have the heat map, that how much correlated are these objectives. So all these different satisfaction objectives are correlated. So if you optimize one, you're going to get the other for free. But you're starting to see some minor neutrality or minor negative correlation with like supply diversity. Like if I recommend more tail artists, then it might hurt user satisfaction. And if I start promoting certain underperforming artists, then this is bad. I mean, users are going to get upset. So this is the problem we have, that in a multi-objective world, you have competing objectives. So sometimes if you optimize for one, you might lose out on the others. So this is where we did this work, which got published last year at KDD. So KDD is another one of those top tier applied machine learning venues. And this is a work which we did with Nianand. So Nianand was a PhD student at Imperial. He was visiting us for the summers last year or a couple of years ago. And this work is basically saying that I have a bandit model and now should make it a multi-objective bandit model. So how do we do that? So for a multi-objective bandit, we should look at a multi-objective function. So instead of just a user function, I should now have functions of each of my stakeholders. And we say that, okay, there's in the economics community, there's a Gini index formulation. So Gini index is used to measure the inequality across wealth, right? In the traditional economic literature. So we adapted that function in the bandit setting. So we said that I want to apply a generalized Gini function, which prefers allocations which are more equitable. So you want to pay enough respect to each of your stakeholder objectives and get each of these metrics high. So I don't want just to care about user, but I also want to care about the artist and the other labels and so on, and then kind of have more equity and more like fairness in terms of like how much respect I give to each of these objectives. So again, this is what the model looks like. Again, I'm not going to go into exact details, but The goal is to find an arm selection strategy. So remember, I was telling you about this action distribution, that how should I pick up my playlist. So we want to learn that function. For each round, we are given a set of features. So these features are anything we know about the user, your time of day, day of the week, where, like, in which region you are, have you listened to Spotify recently, what's your recent playlist history. So these are all features we have. Now, if I choose an arm, okay, if I choose a playlist, then up until now, I was getting one reward, which is the user satisfaction reward, which is what we talked about. But the problem is now I have multiple objectives. So instead of one reward, I should have a vector of reward. So now that's what we do. We say that instead of a single reward, you observe a vectorial feedback. So a vector means that if you have 5 objectives, you're going to get 5 rewards, and then you incorporate that. So basically, like, if you optimize this Gini formulation function, which is what I was talking about here. So instead of that single objective user function, we can now optimize a Gini formulation function, which would give me this multi-objectiveness in my Bandit model. I'm going to skip some of this because, I mean, the details are in the paper and it's in one of the talks. But yeah, so basically, like, if you try this at scale, then we see that some of your multi-objective models perform better. So in general, the takeaway was for us that optimizing for multiple metrics is better than optimizing for that specific metric. So if you look at the metrics we optimized, so it's like clicks, stream time, number of songs played. So some of these objectives help each other out. So these are all user-centric objectives, right? So there's a chaining effect across objectives. So you have to have a click in order to stream for a minute. You have to have multiple streams for a minute in order to have like a long session. So again, there is a lot of sequential chaining effect across these objectives. So there's a structure which the model is able to exploit and learn from. So that's why, like, multi-objective models actually perform better. And the moment we add a competing objective, right, we are seeing that we can get gains in that competing objective without hurting the core user satisfaction metric. Now, this is very important because this means that if you're Swiggy or Zomato, then you can optimize for your restaurant providers. At the same time, you don't have to hurt your users. So that means that's a great thing. It's not a zero-sum game. That if I have to do good for the restaurant providers or for the delivery partners, then there are ways in which you can do that by doing a nice multi-objective formulation so that they gain without hurting the users. So this is a very nice learning for us. Again, we don't know if it's generalizable across all scenarios, but then it's a very promising result that in order to get gains in the business objectives, you don't have to have a loss in user-centric objectives. So if you're doing the matching right, then perhaps you can do benefit across every stakeholder you have. So again, that's the takeaway message that in general, there's an interplay across objectives, and these multi-objective methods are quite useful. We did some other recent work on, like, how do we optimize with limited labels. So if you have a huge neural network, often we have, let's say, like, user clicking and not is very, very popular, but users hearting a track is very rare. So only a few % of users ever heart a track. So now if you train your models, then you have a lot of data about user clicks, but you have very less data about user hearting or banning a track or saving a track. So then there is this, like, imbalance in the data. So how do we train these neural network with this limited labels? Like, we don't observe a lot of label data. Then how do we train that methods? So we had a paper this year which was talking about some momentum damping optimization. So again, if you go into the depths of how neural networks are trained, there's an optimization module there, so we can kind of change some of those optimization to address this limited labels problem. Another example, which is a paper which we have upcoming this year, is on reinforcement learning. So can I kind of plan my road ahead, do long-term planning and optimization, and apply reinforcement learning to some of these problems? So again, this is just to give a flavor of what kind of applied machine learning we would do at kind of Spotify. Right, so if you're interested in this topic, we have a huge tutorial, about 3.5 hour tutorial at KDD. The videos are online as well, which you can walk through if you're interested in any of these problems. But now I get, like, the last 15 or 20 minutes for the most interesting part for me. Cool. So hopefully up until now, I've shown you that, like, just slight flavor of some of these applied machine learning problems you might face at any of these, like, user-centric companies. So now I'm going to give you two things. One is some data sets which we have released publicly, which like you can kind of look at and start playing around with if you want to do research without being at Spotify. And also I'm gonna post some comments on how do we get started with research at Spotify. Also, feel free to use the questions feature here. There are questions. Okay, I'm gonna talk about some of this and then come back. So if in case you're typing in questions, feel free to go ahead and keep doing that. So yeah, there are 3 data sets which I want to talk about. There's a lot of public data sets outside of Spotify, but at Rexis in 2018, we released this 1 million user created playlist. So the goal was to kind of, there was a challenge. And in the challenge, you had to predict the tracks which a user will add to a playlist. So again, there is a data set which has 1 million playlist, and each playlist has a set of tracks, and each track has a set of features. And that's a public data set which you have available, which you can download and kind of do your research on. Recently, last year, we released this data set, actually last year now, on sequential skip prediction. So we have this data set wherein you have user sessions. So often, like outside of the industry in academia, you have this problem that you don't have user feedback, you don't have user level data. So in this data set, we release 1 million user sessions. So again, there's a lot of like anonymization and the legal process which we kind of adopted. But this data set has like sequential user interactions in a session. So if you want to do a lot of like personalization and session-based recommendations, sequential recommendation problems, sequential machine learning problems, you can look at some of this data and kind of play around with it and start doing some research. Recently, last year, like my colleagues at Spotify released this 100,000 podcast. So in the podcast, you have these like 100,000 podcasts, and each podcast has a transcript and the audio. So that's a lot of like NLP and natural language processing and textual and audio format data which you can play around with. So again, just to say that at Spotify, I love the fact that people believe in like giving it back to the community, the academic community, and fostering this industry academia collaboration. Cool. So in the next 14 minutes, I'm going to talk about my best part about the entire my learnings from like research and in general, like how I think like things I wish I knew like when I joined Spotify in 2008. And hopefully, again, take everything I say from now on with like huge grains of salt. And hopefully some of this could be of interest to some of you. I'm just going to take a couple of questions right now. There's a question which has 8 likes. Great. How does the data set for Rexis look like for Spotify? Right. So the data set for Spotify, like, so basically like you have users, right? So you have like 200 million users, let's say. For each user, you decide on what time horizon do you want to look at. Do you want to look at the last 5-year history or just like a random sample of 1 week history? And for each of these, you want to look at like, what are you recommending? Are you recommending playlist? Or are you recommending tracks? Or are you recommending search results? So if you're recommending playlist, then I can look at what kind of user playlist the user has interacted in the last X number of days and then extract features. Now, some of the features we extract are like features we define, like time of day. I mean, some of these like general domain features which you would have, like, is the user familiar with this track? What's the user's affinity for this artist and this genre? So we have a lot of genres and meta genres defined. So you have a user affinity towards this particular genre or not. And then you have a lot of these learned features. So we have user representations which are in itself neural models. So there's like huge, large capacity neural networks which will train vectors for each user. So we have an ML model just for these representations, which get consumed in another ML model for recommendations. And again, like based on the 100 different teams you talked with at Spotify, they would have slightly different versions of what kind of features they want to use. Like, so some of the radio team like relies a lot on recent feedback. So what have you recently? Have you skipped this track? So that means maybe you're not that interested. So there's a lot of like real-time features as well. So again, like it's a very rich heterogeneity in the kind of data sets which we have. I'm going to take another question which had like 7 or something. How do you guys measure the success of model in production? What are the metrics? Great question, right? So this is one of the very, very challenging parts. Like the easiest thing you could do is the user skipping the track or not? That's a dissatisfaction measure. Satisfaction measure is the user is streaming this track, but interestingly, does the user come back to this track in the next 2 weeks? So, I mean, if you want the user to become a fan of the artist, then you want to expose a new artist to the user and you want to observe, did the user come back? I mean, Or was it like a one-off? You saw an artist, you streamed, and that's it, you forgot about it. But maybe you add that particular track to your one of your playlists. That's a great thing. Then you're gonna, if you've added it to your library, you're gonna come back and stream it. So downstream signals are very, very rich and very a true signal of what users actually like. And again, like, you might form a connection with the artist based on how much you stream. So again, like, we want to look at all these factors. One thing, like abandonment rate. So abandonment is like, you start on the homepage, you didn't like anything, you kind of go to search or go to your library. So that's an abandonment. And we want to minimize abandonments because then we were not able to show you content which you might like. We want to optimize for your return rate. Any company, any user-centric company wants you to come back. So they want to minimize the time between your sessions. So if you streamed in today, I want you to come back in the afternoon. Same for Netflix, same for a bunch of other media companies as well. So most of these metrics are around engagement metrics, around return rate metrics, around abandonment metrics, and all these. And there's like hundreds of metrics which kind of different teams compute and kind of look at. Great. I'm gonna come back to some of the questions later on as well, and we can have a longer chat towards the end. But in general, like, I mean, some of the things which I did not know when I joined BITS in 2008, and I wish I knew, because it took me a lot of like information gathering and like talking with seniors and so on to kind of get to know some of these aspects. So with one slide each, I'm going to just mention quickly what are the aspects, and you can refer back to the slides for details. So in general, like, understanding the target conferences is important. So I would say that, like, by in my second year, I had like learned by heart the top tier conferences, because oftentimes you might just see papers from not so great conferences, which might end up wasting a lot of your time. So again, like NeurIPS, ICML, KDD, AAAI, CVPR, these are all conferences based on your areas of interest. So if you're interested in NLP, then ACL is great. Computer vision, CVPR is great. Applied machine learning, KDD, ICML, all these conferences are great. And like, again, like tier one, it's often hard for an undergrad to publish. So you might want to kind of try tier two conferences as well. For students, there are doctoral consortiums and student abstracts. So doctoral consortiums are, if you're a master's student doing a thesis, or a PhD student, then you can submit papers there. And there are different types of papers. So you can have a full paper, you can have a short paper, you can have a poster, or a late breaking work. So again, like, often as student, like when I was at undergrad at BITS, then I submitted a short paper, because full paper usually have a lot higher standard of acceptance and like work requirements. Short paper is something which, if you're doing your projects like SOPs nicely, then you can kind of target a short paper as well. But ideally, the goal is like the more good papers you have as full papers, the better it is. But again, like, you can adjust based on where you are in your journey. If you look at, I mean, there are these websites which give you these rankings. So it makes sense to just kind of have a look at what these top tier, like rank 1, rank 2 conferences are, and just make sure that if you're doing a literature review, then you kind of make sure you cover conferences like these over there. In terms of conference structure, like, they are divided into 3 parts. In the first part, you have tutorials. So as a student, you would love these tutorials, right? Because a tutorial is a dense 3-4 hour session, which will start from scratch and kind of end with the state of the art. So, I mean, you see a lot of these tutorials on YouTube. So follow these tutorials, and you can kind of get very familiar with some of these like recent research directions. There's workshops towards the end of a conference, and these workshops usually give exposure to some recent topics. So maybe there is a lot of information around, a lot of research needed around this information, or some marketplace topics or anything. And these researchers organize workshops on these upcoming topics. So workshop is a way for you to find out what are some upcoming areas which I should be kind of knowing about. And you can look at all these workshops and then find out who those peoples are, and kind of go and look at their profiles and expand from there. So again, if you're interested in finding out what are the recent most interesting topics in a community, in a research area, looking at the workshop titles, going through their description would give you a pretty nice idea. So that's a nice hack which you can use. The publication cycle has like a review period. So you kind of submit an abstract, submit the full paper. There's a few months, 2 to 3 months of review. Sometimes some conferences have rebuttal, which means that here are the reviews. If you have any comments, let us know. And then the final notification happens. So again, like if you're optimizing for your MS or PhD applications, then just make sure that you take this time into account, that oftentimes your paper might not get accepted in the first submission. You might have to redo some work, resubmit, and each resubmission also takes a few months time. So again, just be wary of that when you kind of plan your papers later on. Again, if you're a first year student, shouldn't bother about this. If you already have some research, then like it's a good thing to know. Types of contributions, like there's a lot of types of contributions based on the kind of work you do and the kind of venues you target. So you could start with some insights and analysis. So some of the most amazing papers to read have a lot of good insights which make me think about my problem. And this is where like what kind of machine learning models, what kind of math should I do? So you read a lot of these insightful papers and then find out, okay, what's going on in the community. There's a lot of work around core algorithmic methods. So if you come up with a new multi-objective model, if you come up with a new optimization technique, or you kind of develop new neural architectures. So these are all algorithmic papers which you can write and submit. This is some user study papers wherein you do some evaluation. So you can go to things like Amazon MTurk and kind of do some user understanding, user studies, and write some evaluation papers. There's a lot of application driven papers. So you don't care much about the machine learning problem, you care about the problem you're solving. So, I mean, it could be a specific domain which you're interested in, health or whatever, and then you attack that you want to solve the problem and write an applied paper using some of the existing machine learning tools. So again, based on where your interests lie and what you're comfortable with, you can try different types of papers. So again, like don't just think that only the core ML papers are good or only the application papers are good. I mean, there's a need for all of this in the community. Collaborators, one thing I cannot emphasize enough: find your collaborators. I mean, doing things alone is very, very hard, especially in the university. So again, like you never know. Like, I mean, some of your co-authors might end up somewhere. I worked with a postdoc. He later on went to MIT. I got a recommendation letter from him. So this was great. It worked out well. But 3 years ago, I didn't know he would go and end up in a good place. So again, you can find exciting collaborations with your wingies, like at meetups or like college friends, seniors who want to publish. Alumni, I mean, there are PhD students who are doing research. You can reach out to them and kind of discuss some research ideas with them. And in general, reach out to people. One thing very important is like, don't ever screw up on the problem statement. So I don't want you to kind of go and pick up a problem which is cool in 2004, because we've kind of way past that. So if you're still working on some old aspects of clustering, it's going to be very hard for you to publish, because a lot of work has already gone into that area. And again, if you start with a old problem area, again, not to say that people shouldn't do research on those, right? It's just to say that as a student, there is a way in which you can pick up a more fertile area than an area which is already overpopulated, right? So again, like the chances of acceptance is directly proportional to the quality of the problem statement, right? So as I mentioned, if you pick up some of these marketplace problems, right? So I think they are very cool, and I mean, the industry is just starting to feel the need for these papers. So again, a lot of these companies and a lot of academic groups recently have started writing these papers. So again, this is a hot topic. So now you want to think about what's the next hot topic. And I don't want to do research on topics like matrix factorization, right? Again, it's a great method, some amazing papers you can write still, but then as a student, I would rather increase my chances of acceptance by working on a more recent problem statement. And this is where, like, if you look at the recent workshops, you could get to know, like, how would you know what topic is hot and what topic is cool, what's a nice area. So again, look at recently published papers, look at the recent workshops, right? So workshops are, as I mentioned, a good source of these ideas as well. And again, like, find industry problems which are hard for companies to tackle. And that kind of gives you a foot in the door in the hiring process as well later on. Finally, like, for background work, use Google Scholar and everything. I think this is pretty obvious. But in general, like, be careful when you pick up the related work. Don't go and only look at related work from not so well-known conferences. Again, not to say that they were bad or not, but then with the top-tier conferences, at least there is a proof that we have had a rigorous review period. So that means a lot of senior researchers have looked at the paper and then kind of voted for its acceptance. So there's a higher standard average in general. So again, good papers are also there in not so famous conferences, and bad papers are there in good conferences as well. But in average, at least these tier 1, tier 2 conferences are like pretty reputable. And again, like, finding references, you can look at the citations and like literally backtrack from there and find other papers on the topic. Yeah, writing the paper, different conferences have different styles, and they expect different contributions. So again, try to get a conversation with somebody who's already published in that domain. They will tell you what are the nuances or specific venues. Again, this is for later once you have a research plan. There's a lot of data sets out there, publicly available data sets. So KDD has a yearly cup, and they kind of Kaggle is like very famous right now as well, right? So you have a bunch of different data sets. And again, like if you're creating a new data set by joining a few things together or adding something, then that also adds a minor contribution that you're enriching the community by creating a new data set and making it publicly available. So again, a bunch of things around data. This is one of the learnings which I've had, which I did not realize. So like some of these courses are really great. And like 10 years ago, I did not know that I would use these courses in my day-to-day job at Spotify or during my PhD. So again, like I screwed up my like BITS CGPA, like my GPA for my maths courses was 5. So I was 5 pointer there. But I realized that some of these courses I'm buying books now to kind of read up and understand those topics. So example, probability statistics, the entire career depends on you knowing prob stats very nicely. If you look at the core deep learning models right now, we rely on us creating differentiable functions. So the neural networks exist because we can do auto diff. So auto diff is automatic differentiation. So I don't need to differentiate using the mathematical derivations I used to get before, but understanding differentiation and which functions are convex, which functions are differentiable, which are not differentiable. This is like literally, this is what all the machine learning people who are doing deep learning are doing these days. So again, like hugely important that you pay attention to those maths courses, maths 1 and 2. Again, don't repeat my mistake. Some of the courses I got a D and 1E, or some of these courses, measure theory. So measure theory is a maths B4 course, which talks about measures and like and averages and some of those, right? And these are things which I used last year in one of the methods we deployed at scale in radio. So again, that's a mathematical function which gave us huge metric wins. And I got a lot of like good feedback from my manager at things at Spotify. But all this goes back to us understanding measure theory. So again, like I'm happy to talk about this for an hour because I learned this, that I got a D in that course, and then like I'm kind of learning now that these are aggregation functions. I talked about multi-objective methods, right? So multi-objective means you're looking at multiple things, combining them. Measure theory talks about how do you combine things together. When you're doing that course, you won't realize that how this is related. It took me like 6 years to understand, oh, actually, that stuff did make sense. So again, try to keep an open eye for where these problems might be useful. Some of the work on functional analysis. So if you do a lot of like ICML or Neuriff style papers, the functional analysis textbook is something like I have lying around here now. And I got a C in that course like 8 years ago. So again, like I screwed up. Don't repeat that mistake. If you're working on economics, then literally a bunch of books you see over here are on like market design and economics. So again, like the work I do, like the creator economics, supply side economics, your Zomato does a recommendation model. It has an economic impact on what revenue these restaurants make. So all of these machine learning in big companies have economic implications right now. So that's why, like, if you are doing economic bachelor's, like the master's in economics, then a lot of these courses are very, very important for you, because even the work I'm doing right now at Spotify has a lot of economic thinking baked into it. And if not machine learning, right? I mean, if you're interested in blockchains or crypto, which you should be. I mean, I was interested in machine learning in 2010. I'm interested in blockchains in 2020, because that's where I see the next 10 years of kind of cool work going in. So again, like blockchain is relying on digital economics as well, right? So again, like pay attention to some of these courses, and you'll kind of love it as long as you're able to find the connection. And finally, like when to do research, like SOPs are dedicated time wherein you can pick up a good problem, have multiple rewards. You can write a paper out of your SOP project. You can have dedicated time. You can have a good grade. Find internships, have side projects. Apogee is a good time. A lot of your CSA seniors would love to connect with you to new problems. GSOC, Google Stone of Code, is rarely research oriented, but at least it can get you up and started with some of these data-centric problems. And a lot of these applied machine learning problems are becoming some GSOC problems as well. So again, the sooner you start, the better, but also it's never too late. So don't kind of do all this at the expense of your course curriculum. And there's a lot of side benefits, which I don't know if I need to say this or not, but then like I've traveled a lot with these conferences, like on a yearly basis. Even at BITS, I got some travel grant to go to Ireland to kind of present my work. I met my PhD supervisor there. So again, if you write a good paper, they will fund your travel, and then you might meet some professors who might become your PhD supervisor later on. So it's a great community. And like there are Microsoft Research Travel Grants. SIGIR has huge travel grants to support students. So keep an eye out on those. Again, a lot of the research you do is fertile grounds for networking. You meet top researchers, and a lot of these conferences are flooded with recruitment people as well. And again, like internships, I love internships. Even if you go and do your master's or PhD later on, then internships allow you to do some very cool research during your PhD as well. So that's it. That's a summary of some side comments. And with that, I think I'm literally at the hour mark. And yeah, so yeah, to summarize, I started by just giving you a flavor that I was with CSA. And I love the fact that we're still continuing art. So thanks a lot to all the organizers who are doing it. And in general, I kind of talked about some of these machine learning problems on a user-centric system, but more recently on a multi-objective marketplace system. And then we just briefly discussed some important aspects to keep in mind when you're kind of getting started with research. I'm going to take some questions, but feel free to get in touch with me. I'm mostly very, very active on Twitter. So Rishabh is my Twitter handle, or just kind of feel free to drop me an email or Facebook, literally wherever works. So I presume I can take a few questions for the next 5 minutes. I don't know how much we're doing with time as well. So Varun or others, let me know whenever you think we should stop. Okay, so I'm going to pick up some questions. Which is, one is like, how is it decided that a particular track falls into the category of getting ready for work or chilling out? Does this require user preferences or grouping, like finding what people listen to while getting ready to work? So there's a great question by Costa. So the question is like, how is it decided that a particular track falls into a particular intent? Like this is getting ready for work, or this is like chilling out in the park. So great question. So, and this is not a problem just for Spotify, right? I mean, if you look at TikTok or Instagram videos as well, then they are able to identify the themes that you're watching some like funny cricket videos or funny cat videos, and then subsequently you get cat videos as well. So I think there is a lot of like metadata understanding which goes behind these models. So the goal is that if I can tag some of these tracks with like content descriptors. So this track is about this genre, or this track is about party music. You can look at the playlist people have around these tracks. So if this track occurs in like religious playlist, then this is a religious track perhaps. Or you can kind of ask your domain expert. So we hire a lot of these data curators who are music experts, and we show them certain content, ask them for giving us tags. And then we can create an ML model to kind of automatically tag content. So metadata tagging is a very, very important tool in any industry. If you look at TikTok videos, they have huge amount of humans employed just to tag each video people upload. So once you know those tags, then that's features for you. And then you can do machine learning on top of features and ensure that your subsequent recommendations are in a very similar feature space as the metadata of the current track or the current video on TikTok. So again, a lot of work around there. And again, you can also develop, if you create a data set, right? Mini data set of, can I look at a picture and create an image tag? Can I look at a video and create a tag? Can I look at a track and find out what it's about? So maybe if you have enough data, you can create an ML model for that. So people have done this. Like they've looked at an image, and the output of the model is a caption. So image captioning is a very important and well-researched problem in the computer vision community. So again, you can do the same with audio. So with audio, we have a lot of these danceability, instrumentalness, tempo, and all these features which are extracted from the pure audio content without even looking at what the lyrics of the song is. Again, you can look at the lyrics as well, and then infer some of these attributes as well. There's a question about lyrics from Harshit. Spotify recently added time sync lyrics. Are the lyrics detected through speech to text, or is it through crowdsourced time syncing? Great question. Unfortunately, this lies slightly, again, because this is a recorded talk and it's like on YouTube as well. I cannot exactly tell how that team is doing it because I don't have the PR permissions to do that. But if I was Ghana.com, right, then like I would start by, I would start by just like text to speech and speech to text and see like how it performs, and then kind of have some mechanisms wherein like people can say this is wrong and then you feedback. So basically like have a model and kind of deploy it, see what happens, and then like as long as you have the way to get feedback that this was wrong and you update your model, I think that feedback loop is very necessary across different machine learning models. There's a question from That's it. Prabhav, RL is resource time and intensive technique for getting the desired results, mapping new area. Okay, but Spotify wants to give the user the best recommendation in ASAP. How is RL utilized? Yeah, so I'm going to answer this question. So again, Prabhav asked this question. Like RL is very resource and time incentive, right? So and usually for long term. So how can a company like Spotify or any media company use RL? So my answer over there is like think about like the long term frame, that as a user you not only want things you're familiar with, but you want to grow your taste. So you want to discover certain artists, or you started liking that Enrique song and you want to explore more what's out there. So again, some of these decisions are not just the current session decision. Some of these are like, where are you headed in your music discovery journey? So same for Instagram, same for Reddit, same for Facebook, same for LinkedIn. So I mean, we want to inculcate these long-term habits in users. So Facebook wants you to listen to maybe more look at more videos. So if you're on Instagram, they want you to go to the reels on Instagram. So again, there are habits which these platforms want to inculcate in you. And RL model need not, again, you can apply RL on the current session, that I'm going to look at what the user did, incorporate the feedback, and then kind of come back with a better version. Or you can apply it on a more large scale time frame, that these are the habits I want to inculcate in users. I want users to discover more content. I want users to kind of become a fan of this artist. So these are like long term. I mean, you don't become a fan like you like immediately, right? So I mean, you have to stream an artist continuously, come back when the artist releases a new track. You want to keep an eye out and then kind of become a fan over a period of time. So again, a lot of these problems are long term problems. So RL could be used there. Again, I'm not saying how RL is used because I cannot say that publicly, but just in general, like how the media companies tackle this problem. There's a question from Satyam: how to improve matrix factorization without going into tensor based? So matrix, yeah, that's a great question. So so matrix factorization says that I have a matrix of user and items, and I want to learn representations. So the best way to do that is do the collaborative neural filtering, right? So I showed the model later on, wherein you're trying to combine the word-to-vec embeddings with matrix factorization. So again, the moment you bring matrix factorization into a deep learning neural framework, then you have a lot of power in your neural network. So neural networks allow me to bake in any functionality I want, and kind of make the architecture very representative of what I want to encode. So again, like I would say that the sooner you bring in your matrix factorization into a neural network, the more you can kind of rely on the current advances in the deep learning community to kind of add richer functionalities. So if you have side information, then all I have to do is like pass through. You can do RL on matrix factorization as well, right? So you cannot do that just in a pure optimization sense. But the moment you bring all of these things into the network architecture, then you can build any high capacity neural network as you want. There's a question from Manthan. Being a student, we don't have access to resources apart from Colab. Do these conferences really tasks which can be solved with lesser resources? That's a great question. I think like some of these, first of all, like Colab has decent enough resources, but there's like Amazon grants as well. So if you're a student, you can apply for Amazon AWS credits, and even like Azure might have some of those. So you might get like $100 if you apply, and like that might be enough for you to kind of run some high capacity neural networks for a long period of time. But also, so there are two ways over here, that if I have limited credit on Colab or on AWS, then you don't want to do like your iterations, model iterations there. So I usually pick up like a very small subset of data which I can run on my laptop, and then see what kind of changes I want to make, faster iterations on my laptop, and then once I have something good enough, then I kind of go back to the main and kind of do that there. But I think like the bottom line is you should be able to go very far with even the Colab setup you have, and at the same time you should like just look out for all of these companies giving you free credits on different cloud platforms, and they do. So I've kind of benefited a lot from the Amazon credits as well. And if not, then just reach out to those people, and like ACM, like BITS should have an ACM chapter, and you can hopefully like set something up with some of those people as well. BITS also has like cluster computers, at least back when I was there. So we had access to those computers, which you can try to kind of get access to as well. Somil has a question. We often find ourselves struggling on what career path to choose as an undergraduate ML researcher. Three major parts as do a post graduation, become a professor, do a post graduation, join a corporate job, go for a job? Yeah, I think like there's no right answer or wrong answer here. I think like I usually the process I followed was just defer my decision, because in the first year I did not know what I want. I just kind of tried to do things which seemed like long term fertile. So again, like start with machine learning. If ML is an interest area, then you can start with some machine learning problems. Again, like if you're solving these Kaggle competitions, if you're kind of doing some mini project, mini research, then even if you go to a job, it will help you there. Even if you apply for a master's or PhD, it will help you there. When I went in my PhD program, I did not know whether I wanted to even stay the entire duration. But I mean, PhDs are usually funded, so that gives you the time to think through on what you want, and then kind of make a decision. So again, be very mindful that you don't have to commit to something right now. There's a lot of common problems which will help you across each of these three. And interestingly and thankfully, machine learning has a lot of these opportunities wherein if you do some research, which will help you to become a professor or get a PhD position, get a research job in the industry, or even become an ML engineer, like literally right after your undergrad. So a lot of the problems which we face as researchers are like we work very closely with the ML engineers on teams. So again, like when I'm doing research, I'm not just as a researcher, I go and work as an ML engineer as well. So in the applied machine learning community, a lot of this is common. So you want to kind of you want to pick up these problems or these projects which will help you, like regardless of what future direction you might want to take. There's a couple of recent questions on by Mitesh. Supply and demand side have their own separate applications, consoles. Why need for multi-stakeholder modeling? So supply and demand usually has gone, a lot of work has gone in the economic side of policy making, right? So government makes policies based on supply demand. Like your municipalities make like policies based on this. But often in the industrial user centric systems, I mean, if you look at Google, like Google search was mostly user centric. They want to minimize user dissatisfaction, maximize user satisfaction. So generally, what has happened is that supply demand has been mostly the economic thinking, and now things are merging. That when you're Uber or when you're Zomato or Swiggy, then like you have to bake in, learn from these economic modeling and apply it over here. And a lot of the problem is like your machine learning models up until now were not aware of these economic concepts, right? So in a machine learning model, you're having a neural network optimizing for some objective, and they have no clue what the economic implications of these models are. And even in the current date, a lot of the systems, they are kind of having unintended effects and like economic implications, which we did not create that system for. So again, that's why like even though supply demand side have been very rich, but that's the newer community. Now the machine learning community and the ML model, ML practitioners should start to kind of become more aware and try to kind of cross collaborate and like bring in and combine insights from both. I think this is fairly common. Like there are separate research areas and topics, and then like the nice part are like the rich heterogeneous multidisciplinary research which you can do. And that's also another important takeaway that I learned, that if you're bringing insights from multiple communities, then your research is a lot more solid and grounded than if you just have a very single dimensional view to problems. Okay, so I'm not sure like how we are doing on time. Could somebody mention if you want to stick around and answer a few more questions? Maybe I can take one last question. So Mansi asked this question: what goes into creating unique song radios for each song on Spotify? Great. So this is exactly what I was doing in the last 6 months, and we kind of productionize a model across 300 million users. So if you're using the Spotify radio, that model is something which me and my team worked on. So right now, that model is a mix of multiple goals, right? And some of the goals are that you want to listen to tracks right now, which you might like. We also consider that you want to discover new content. So some users want discovery, some users don't want discovery. So we have some aspect of that we understand what users want, and then kind of add in a discovery, add in like non-discovery tracks as well. We add in tracks which you have listened to and you've loved. So it's a multi-objective mix of the things you already have learned, already have liked and loved in the past, and a mix of what we think you might want to discover. So there's a bunch of new artists, new tracks, and we're kind of learning about your preferences as well there. And again, it's fresh. So each time you come back, you get a different ranking, which is slightly different. And some of the decisions are, can I show you one track, Mansi, which will tell me more about your interest, which I do not know? So the exploration I talked about in the bandit setting, some part of that is there in the randomization we do in your radio as well. Cool. I think that's about it.
Uh, so we can end it here, and if some students have some doubts, maybe we can do it in face-to-face manner on the lounge.
Yeah, great. So thank you so much for attending. And that's it from me. Feel free to get in touch on Twitter or wherever. And hope you enjoy the rest of the Alumni Research Talks as well.
Yeah, thank you for joining us, Rishabh sir, today. I think that was a very enlightening talk. Gautam, I think your mic has some problems. That's why none of us could hear you. Uh, I think the entire speech was an eye opener for many students and a goldmine for all the students interested in AI and ML. I thank you on behalf of Computer Science Association and the whole BITS community present here for this very enlightening talk. Right now, we're going to play a short video about the promo of ART, about the promo for ART, and I think immediately after the talk, if you have time, then you can join us in the lounge, and people will be asking all sorts of questions over there.
Sure. Yep. I'm happy to join along there. How do I exit lounge?